moving on to this idea of even or odd. So when we're talking about functions, we can have even functions or odd functions. And I'm going to start here with their definitions, and these are actually their algebraic definitions. And then we'll take a look at a couple functions and see what that actually means. So first of all, algebraically, an even function is if f of x equals f of negative x. Now, what that means graphically is your graph is going to be symmetric to the y-axis. So a good example of an even function is our quadratic function. So if I have my x and y-axis, my vertex is on 0, 0, there's my quadratic function. And if it's symmetric to the y-axis is right there, that's your axis of symmetry. It kind of cuts it in half, so you can fold it over that y-axis and it's going to land right on top of each other. So if you have a graph that does that, where it kind of like folds right over the y-axis, that's going to be an even function. Now an odd function is when f of negative x equals negative f of x. And make sure you're paying attention to where those negatives are. That's going to come into play. And what that means is your graph is going to be symmetric to the origin. Keep in mind that the origin is 0, 0. So an example of this, I'm going to draw my x and y axis. And then a good example of this is your linear graph. So 0, 0, and then he looks like that. Okay, now usually how I like to think about this, and I'm going to see if I can do it real quick. Nope, that's not what I wanted to do. Let's see if I can grab this guy. There we go. So a good example of an odd graph is take a look at this graph. It's coming out of 0, 0. It's going up to the right, down to the left. I'm going to take the graph and spin it upside down. Do you notice it's still going up to the right and down to the left? So an odd graph, if you take your paper and just like flip it completely upside down, will look exactly the same. It looks like that linear graph. I flip it, it looks like that linear graph. So that's a good test to do for an odd function, whereas it's symmetric to the origin, is you can spin it around like that and it looks the same. A zero of a function is x intercepts where graph hits x-axis. Okay, now for our purposes, we've used the word roots before. Roots are the solutions to a quadratic function or to a function. Zeros are a little bit different. These are actually x-intercepts where the graph hits the x-axis, but for our purposes, they're going to look kind of similar, and later on we'll talk about the differences between a zero and a root, but for right now, they're kind of the same thing. Examples. Let's start out first of all with this idea of even, odd, or neither. So we have to determine if each function is an even function, an odd function, or a neither function. So when you do this, everybody's going to start with even. Now, if a function is even, we said that f of x has to equal f of negative x. Okay, right here, this is f of x. So the next thing I would have to figure out is, okay, well then what's f of negative x? Meaning, take your function and substitute in a negative wherever the x is. So f of negative x is going to equal 2, and then instead of x, I'm going to substitute in negative x. If you simplify that, f of negative x equals, well, 2 times negative x is simply negative 2x. That is f of negative x. Then you're going to take a look at these. Is 2x the same as negative 2x? No, so it is not even. So then the next test we're going to do is we're going to say, okay, well, maybe it's odd. And for odd, we said that f of negative x equals negative f of x. Well, the good news is f of negative x we already have. It's right here in this red box. So that means the next thing we would need is we would need negative f of x. So negative f of x means you're going to take your function and you're going to put a negative in front of it. So remember your original function was just 2x. So we're going to take 2x and we're just going to say negative 2x. If we kind of simplify that, that is negative 2x. And that is your negative f of x. So then we're going to take this guy and compare it to this guy. Okay, so notice for your odd, you don't go back to the original function. You start with that f of negative x in the middle. And what do you notice about the red negative 2x and the green negative 2x? They are the same, which means this is an odd function. That's your answer. This is an odd function. Now, the other way to look at this is graphically, which in this case, if you can do graphically, do graphically. It's a whole lot easier. So graphically, I'm looking at the function 2x. 2x is a line. If you guys remember, y equals mx plus b. This is y equals 2x plus, there's no b, so I'm going to put a 0. So it actually goes through 0, 0. And then it has a slope of rise 2, run 1. Rise 2, run 1. Rise 2, run 1. And then we could drop 2, run 1. But anyways, this is the graph of a line that goes through the origin. And remember we talked about that an odd function is symmetric to the origin. So this is symmetric which would be another way to show that this is an odd function. Let's try again. H of x equals 2x squared plus x minus 2. So the first thing we're going to test for is we're going to test for even. So if it is even, then f of x has to equal f of negative x. And f of x is right here, which in this case I should do h of x. This is really h of x. But now we need to find f of negative x, meaning wherever there's an x, we're going to substitute in a negative. So we're going to do h of negative x. So 2 negative x squared plus negative x minus 2. Then we're going to simplify. H of negative x. If I have a negative and I square it, what's a negative times a negative, people? That's a positive. So really, this negative is not necessary because we're going to square it. And then we're just going to get a positive out of it anyway. So this first term just turns back into positive 2x squared because of the squared. Now, plus negative x. Is this going to go back to positive? No, because there's nothing squaring it. So if you're adding a negative, this is really just minus x. And then you just have minus 2. Here is h of negative x, and we compare. Are those the same? And the answer is no. This one has a plus x, this one has a minus x. That's so not even. So then the next thing we have to check for is we have to check for odd. So odd is if f of negative x equals negative f of x. And once again, we already know this because we just found it. So now we have to find this, which means take the original function, stick a negative out front. So negative h of x equals negative, and then we have the original function. So the original function is 2x squared plus x minus 2. If we simplify, negative h of x equals, I'm going to distribute that negative, so negative 2x squared minus x plus 2. There's my negative h of x. So now I compare this guy to this guy. Okay, remember for odd, you don't go back to the original function. You compare the step you did for even with the step you did for odd. Are these, the one I have in blue, the same as the one I have in green? And the answer is no. This one's positive, this one's negative, this one's negative, this one's negative, this one's negative, no. So not odd, which means this guy is neither. Now, if we tried to graph this to look at it, I want to graph this guy because if it's neither, it shouldn't be symmetric to the y-axis and it shouldn't be symmetric to the origin. We don't know how to graph that yet because so far we've only been dealing with vertex form and this is in standard form. So I want everybody to go down here. I want you to get a web browser. And then I'm going to write 2x squared plus x minus 2. So in my web browser, you're going to type in desmos.com. You're going to get your graphing calculator. And then over here, you're going to type 2x squared. And then I think it was plus x minus 2. Let me go check. Plus x minus 2. So plus x minus 2. And there's your graph. Now, if this was even, it should be symmetric to the y-axis. There's the y-axis. Can you fold this thing over the y-axis and have it land on top of itself? And the answer is no, because it's shifted to the left a little bit, right? So it would have to be right on the axis. And is it symmetric to the origin? No, it doesn't even cross through the origin. If you were to turn this graph upside down, it wouldn't be the same. So graphically, this is how you would look at it graphically and go, oh, okay, it's not even. I can't fold it over the y-axis. It's not odd. I can't turn it upside down. So that is why algebraically we said neither. Next one, g of x equals x squared minus 2. So I'm going to move a little bit faster. If we're trying to figure out if this is even, f of x has to equal f of negative x. So f of x is right here, which actually in this case is g of x. We need to find f of negative x. So g of negative x, substitute in negative x squared minus 2. Simplify. Negative x squared, a negative times a negative pops back out to be a positive. And then you have a minus 2. Here is your negative x. And then we compare. What do you notice? They're the same. Which means our test for even worked out. This is an even function. And you can stop. If it's an even function, we're not going to go test it for an odd function. We're done. Now, graphically, we could go back to Desmos on this guy. But you already know how to graph this. We can use transformations. This is a quadratic function, which means it's going to make a parabola. And the minus 2 means we're going to move it down 2. So it would start at 0, 0. We go down 2. We put our new vertex. Then, because there's no a value, we just go over 1. Up 1, over 1, up 1, over 1, up 1, and we graph. Now, if it's even, which we just said it was, it should be symmetric to the y-axis. Meaning, can you fold it over the y-axis and have it land right on top of itself? And the answer is yes. So this is definitely an even graph. Last but not least, letter D, even, odd, or neither. So I'm going to start with even. f of x equals f of negative x. F of x, in this case, we're talking about g of x, is right there. Meaning now we have to find f of negative x. So g of negative x equals 2 to the power of, substitute in, negative x. What the heck is that? That's a negative exponent. And then as we're doing this, I want to look at, okay, wait a minute. When we start with g of x equals 2 to the power of x, what type of graph is this? Okay, this, if you remember, is exponential. Do you guys remember what an exponential graph looks like? You have exponential growth. You have exponential decay. So an exponential graph, I've got a positive base here. This is going to be exponential growth. Is going to look like that, roughly. Okay, you can grab Desmos, do something a little bit more algebraic here. But now I'm looking at the graph going, wait a minute, if this is an exponential graph, is that symmetric to the y-axis? No, which is why I'm looking at these going not even. I don't even know what this negative thing is. It's confusing me, but you know what? Graphically, it's not even. It's not symmetric to the y-axis. Well, I could keep going here and test for odd, but is this thing symmetric to the origin? Like, what's going to happen if I take this graph and flip it upside down? Let's see if I can do it. Does that look exactly the same as what I started with? And the answer is no. So if it's not the same when I flip it upside down, guess what? It's not odd. So for this one, I'm just going to say neither. And then I would probably write not symmetric to y-axis or origin. So instead of proving this one algebraically, doing our f of x and f of negative x and all that stuff, I would just prove it graphically and say, look at the graph. It's not symmetric to the y-axis. It's not symmetric to the origin. So I'm not even going to waste my time on the algebra. There you go.